So the question says find a and b such that the integral a to b of u squared plus 1 du becomes the integral negative pi over 4 to pi over 4 secant to the fourth of du. So take a look at secant to the fourth. Secant to the fourth can be written as secant squared times secant squared of theta. Well, let's go back to u squared plus 1 du. If u is tangent of theta, du becomes, remember that tangent is sine over cosine. If you take the derivative with respect to theta, this guy becomes the derivative of sine, which is cosine, times cosine, cosine squared, minus the derivative of cosine, which is negative sine, so you get a plus sine squared theta, divided by cosine to the second power of theta, which is 1 over cosine squared of theta. So this guy can be written as secant squared of theta d theta. So again, if my integral use the substitution u equals to tangent theta, you get tangent squared plus 1, and du is going to be secant squared of theta d theta. Okay, so far so good. But we know that 1 plus tangent squared of theta is nothing but secant squared of theta from pre-calc. And you have another secant squared times d theta. So secant squared of theta d theta. As you can see, you created the right-hand side, secant to the fourth. Very good. Now that you have secant to the fourth, you have to just use the u sub to find the boundaries a and b. So if u is tangent of theta, b becomes tangent of pi over 4, which is sine pi over 4 divided by cosine over 4, which is 1. And a is tangent of minus pi over 4, which is negative 1. So a is negative 1 and b is 1.